You've got a lawn that takes up half an acre or more, and every weekend you're out there pushing a mower for an hour, sometimes longer. There's a better way. Robotic mowers promise to handle all that work while you control them from your phone. But here's the thing. Most of them can't actually maintain a reliable connection past 50 feet from your router. I'm Marcus Chen, and I've spent years installing smart home devices across the Pacific Northwest. I've watched too many homeowners buy expensive robotic mowers that promise seamless coverage but end up leaving random uncut patches because of Wi-Fi dead zones. You're listening to Smart Home Setup Podcast. Quick note before we dive in. The research, the data, all the script work, that's 100% human verified and written by real people who've actually installed this stuff. The voice you're hearing, though, that's AI generated. Just want to be transparent about that up front. If you've been listening to episodes regularly, thank you. It means a lot to know this content is landing with people who are actually trying to make smart decisions about their setups. If this is your first episode, welcome. Glad you're here. We drop new episodes every Monday, Wednesday, and Friday, and we focus on smart home products from an installer's perspective, not a reviewer's. Now, let's talk about robotic lawnmowers for large properties and why most of them fail the moment you get past half an acre.
If you need true large yard coverage, we're talking 1 acre or more, you need to prioritize models with RTK GPS or built-in cellular connectivity. Standard Wi-Fi alone is going to leave you frustrated with dead zones and incomplete cuts. Large yards present challenges that smaller properties never have to deal with. Wi-Fi dead zones are the big one, but there's also perimeter wire installation across complex terrain and integration friction when you're trying to coordinate mowing schedules with smart irrigation controllers or other yard automation systems. This isn't just about cutting width and battery specs. What actually matters is the protocols, the hub requirements, and the automation logic that determine whether your mower becomes a reliable part of your smart yard ecosystem or just sits there like an expensive paperweight. Now, let's talk about what you actually need to look for when you're shopping for these things. Most robotic mowers use Wi-Fi, specifically 2.4 gigahertz, for app control and cloud connectivity. But large yards expose Wi-Fi's fundamental weakness, which is range. A typical home router reaches about 150 to 200 feet outdoors in ideal conditions. That's less if you have trees, landscaping, or elevation changes in your terrain. If your property exceeds half an acre, you need one of 3 solutions. First option, built-in cellular connectivity, like LTE or 4G. The mower maintains its own connection independent of your home network. Second option, RTK GPS navigation, which reduces dependency on constant cloud connection because the mower can operate semi-autonomously. Third option, Wi-Fi mesh extenders that are rated for outdoor use, strategically placed to cover your mowing zone. Here's something homeowners consistently underestimate: how much foliage and terrain affect signal strength. I've seen setups where the mower worked perfectly in spring but lost connection in summer when the trees leafed out. That's a real thing. Important compatibility note here. Robotic mowers do not use Zigbee, Z-Wave, Thread, or Matter protocols as of 2026. They're Wi-Fi or cellular devices that connect to your smart home ecosystem through cloud-to-cloud integration, Amazon Alexa, Google Home, Apple HomeKit, or via API calls if you're running Home Assistant. This means your automation logic runs through internet servers, not locally. Expect 2 to 5 second latency for manual commands, and you've got cloud dependency for all remote control features. Moving on to coverage capacity versus real-world terrain. Manufacturers list maximum acreage ratings, but these assume flat, obstacle-free lawns. Real yards have slopes, tree roots, flower beds, irregular shapes. All of that reduces effective coverage by 20 to 30%.
Key specifications to evaluate. Slope tolerance, measured in degrees or percentage. Most handle 15 to 20 degree slopes. Premium models manage up to 35 degrees. Cutting width. Wider decks, like 10 to 12 inches, cover ground faster, but they struggle in tight spaces. Battery runtime versus recharge time. Large yard mowers should run 2 to 3 hours and recharge in under 90 minutes. For properties over 1 acre, look for models that support multi-zone programming. This lets you create separate mowing schedules for front and backyards, or high-traffic versus low-traffic areas. The automation logic works like this. If the current day is Monday and the time is 10 a.m., then mow the backyard zone at 3.0-inch cutting height with a random pattern. Else, if the current day is Thursday and the time is 8 a.m., then mow the front yard zone at 2.5-inch cutting height with parallel lines pattern. Let's get into perimeter definition methods. Large yards make perimeter wire installation a significant project. You'll need to bury or stake wire along every boundary, around flower beds, near fences, often 500 to 1,000 plus feet of wire for properties over 3/4 of an acre. There are 3 perimeter systems. Boundary wire is the most common. It requires physical installation, but works reliably regardless of signal conditions. Expect 4 to 8 hours of labor for initial setup. RTK GPS is found on premium models. You walk the perimeter once with a handheld controller. The mower maps boundaries via satellite positioning with accuracy down to 1 inch. No wire installation, but it requires clear sky view and struggles under heavy tree cover. Vision-based AI is emerging technology. Cameras and sensors identify lawn edges, but reliability drops significantly on properties with ambiguous boundaries, like gradual transitions to naturalized areas. Fallback behavior matters. If the mower loses GPS signal or boundary wire connection, does it stop immediately or does it continue until it hits a physical obstacle? In my installations, I've seen vision-based mowers wander into gravel driveways when lighting conditions changed. Wire-based systems offer the most predictable failure mode. The mower stops when it reaches the wire, period. Now, smart home integration depth and automation options. Works with Alexa, doesn't tell you much. Here's what you actually need to know. Basic integration, which is what most models offer, voice commands like Alexa, start the mower, or Hey Google, pause the mower. App-based scheduling and manual control. Push notifications for completion, errors, or maintenance needs. Latency is 3 to 8 seconds from voice command to mower action because of the cloud round trip.
Advanced integration, which you'll find on premium models or if you set things up with Home Assistant. Weather API integration that automatically skips mowing if rain is forecast within 3 hours. Soil moisture sensor coordination that delays mowing if irrigation ran recently and grass is wet. Energy management that charges during off-peak hours if you're on time-of-use electricity rates. Security system coordination that disables mowing schedules when you're home but the yard is occupied, like when kids are playing outside. The automation logic for weather integration might look like this. If the weather forecast for the next 3 hours shows precipitation probability greater than 60%, then cancel the scheduled mow and reschedule for 6 hours from now. Else, execute the scheduled mow. Critical limitation here. Because robotic mowers don't use local smart home protocols, your automations must have internet connectivity to function. If your home internet goes down, you can't trigger mowing via app or voice. Only the mower's onboard schedule will continue. This is fundamentally different from Zigbee or Z-Wave devices that can run locally through a hub. Let's talk about maintenance requirements and sensor reliability. Large yard mowers run longer and cut more grass, which means more frequent blade replacement and cleaning. Expect to replace cutting blades every 2 to 3 months during growing season. Some models use small pivoting blades that you replace in sets of 3 to 6. Others use fixed bar blades that you replace as a single unit. Sensors that affect reliability. Lift sensors stop blades immediately if the mower is picked up or tips over. Collision sensors detect obstacles and change direction. These can be optical, ultrasonic, or physical bumpers. Rain sensors send the mower back to the charging dock when precipitation starts. I've seen homeowners frustrated by overly sensitive rain sensors that abort mowing sessions because of morning dew or sprinkler overspray.
Better models let you adjust sensor thresholds or disable rain detection entirely. That's useful if you're coordinating with smart irrigation systems that water at predictable times. Security features and theft prevention. A robot that costs $1,500 to $3,500 sitting in your yard attracts attention. Pin lock and GPS tracking are non-negotiable for large yards, where the mower operates far from the house and may not be visible from windows. Security features to prioritize. Pin lock, so the mower won't operate without entering a code on its keypad. GPS tracking, so you can locate the mower via app if it's stolen. Requires cellular or active Wi-Fi connection, though. Geo-fencing alerts, so you receive a notification if the mower leaves your property boundaries. Lift alarms, an audible alarm sounds if someone picks up the mower while it's operating.
Fallback consideration: if the mower is stolen and taken out of Wi-Fi range, GPS tracking only works if the model has built-in cellular connectivity. Wi-Fi-only models become untraceable once they're off your network. All right, let's get into the specific models. The Husqvarna Auto Mower 450X EPOS is the most reliable large yard mower I've installed. It's designed for properties up to 1.25 acres with RTK GPS boundary definition that eliminates perimeter wire installation. It uses satellite-based positioning with a reference station you place in your yard, achieving 1-inch boundary accuracy even on complex properties with irregular shapes. Check the link below to see the current price. Pros: no perimeter wire required. You walk the boundary once with a handheld controller to define mowing zones. Built-in cellular connectivity via LTE, so it maintains cloud connection independent of home Wi-Fi for reliable app control and GPS tracking. Handles slopes up to 24 degrees, which works on most residential terrain without traction issues. Multi-zone programming with separate schedules. You can define different cutting heights and frequencies for up to 10 zones. Weather API integration automatically adjusts mowing schedule based on forecast, though that requires a subscription after the first year. Excellent smart home integration with Alexa, Google Home, and IFTTT support for custom automations. Cons: requires cellular subscription after the first year. It's around $10 to $15 a month. Without it, you lose GPS tracking, remote app control, and weather integration. The reference station needs clear sky view. GPS accuracy degrades under heavy tree cover or near tall structures. The companion app is occasionally laggy. I've seen 5 to 10-second delays when loading mowing history or adjusting schedules during peak usage times. The EPOS uses a reference station that you mount on your roof or in an open area of your yard. It receives satellite signals and transmits correction data to the mower for precise positioning. This is the same technology used in precision agriculture and surveying. If you have sections of your property with dense tree canopy, the mower may struggle with boundary precision in those areas. You're looking at 6 inches instead of 1-inch accuracy. An automation logic example for multi-zone coordination: if soil moisture sensor in Zone 1 is less than 30%, then skip mowing Zone 1 and log an event that says skipped Zone 1, soil too dry. Else, if the time is 7 a.m. and the day of the week is Monday, then mow Zone 1 at 3.0-inch cutting height with systematic pattern. The Works Landroid Pro WR147E offers the best value for homeowners with 1-acre properties who are willing to install boundary wire. It's got excellent app-based zone management and reliable Wi-Fi connectivity when paired with outdoor mesh extenders. Check the link below to see the current price.
Covers up to 1 acre on a single charge, 3-hour runtime with a 90-minute recharge cycle. AIA navigation, that's artificial intelligence algorithm, learns your yard layout over time and optimizes mowing patterns for efficiency. Modular accessory system, so you can add a GPS module, 4G/LTE module, or voice control module as needed. Cut-to-edge design with a 10-inch cutting width and offset blade placement gets within 1 inch of boundary wire. Works with Home Assistant with local API access available for custom automations without cloud dependency. Handles narrow passages down to 24 inches, which is better than most large yard mowers for properties with side yards or gate areas. Cons:
Requires boundary wire installation. Budget 4 to 6 hours for a typical 1-acre property or pay for professional installation. Wi-Fi range limitations mean you'll likely need outdoor mesh extenders for properties over half an acre. I've had success with ubiquity outdoor access points placed strategically. Rain sensor is overly sensitive and frequently returns to dock during heavy dew. You'll want to disable it if you're coordinating with irrigation schedules. The modularity is genuinely useful. You can start with the base model and add the 4G module later if you realize Wi-Fi coverage isn't sufficient. The GPS module is a separate purchase, around $100, and it provides theft tracking but doesn't affect navigation. This mower still uses boundary wire for perimeter definition. For Home Assistant users, local API access means your automations can run without internet. If the Landroid battery level is less than 20%, then send a notification that says, Landroid battery low, check for wire break or obstacle. Else, if the outdoor temperature is greater than 95 degrees Fahrenheit, then call the service to pause the Landroid and schedule resume for 6 p.m. when temperature drops in the evening. The Segway Navimo i105E uses EFLS, Exact Fusion Locating System, that combines GPS, GLONASS, Beidou, and Galileo satellite positioning. No boundary wire and no separate reference station required. It's the easiest large yard setup I've encountered. Check the link below to see the current price. Covers up to 1.25 acres. Pros: true wireless perimeter setup. No wire installation, no reference station. You walk the boundary with the mower itself. Works in areas with moderate tree cover. Multi-constellation GNSS provides better signal reliability than GPS-only systems. Handles up to 1.25 acres with systematic parallel line mowing patterns that look professional. Real-time obstacle detection with front-mounted ultrasonic sensors that detect objects down to 8 inches and route around them. Built-in 4G/LTE with no subscription fee as of 2026. This is unusual and valuable for remote control. Slope capability up to 27 degrees handles most residential terrain.
Cons: battery life is shorter than competitors. 90-minute runtime means more frequent return trips to charging dock on larger properties. The companion app lacks advanced scheduling. You can't program different cutting heights for different zones or create conditional logic. Struggles with narrow passages, requires at least 3 feet of clearance. Won't navigate typical side yard gates without manual intervention. The multi-constellation approach means the mower can usually maintain position accuracy even when some satellites are blocked by trees or structures. It needs a view of only 6 to 8 satellites across all constellations versus 12+ GPS satellites for similar accuracy. This makes it more reliable than single-system GPS in partially wooded yards. Major limitation for smart home integration: the Navimo's app doesn't support IFTTT, Alexa routines, or Google Home custom automations as of early 2026. You get basic voice commands like, Alexa, start the Navimo, but you can't create conditional triggers like skip mowing if soil moisture is above X%. If you're building a coordinated smart yard automation system, this is a significant weakness. The Momotion Luba 2 AWD is purpose-built for challenging terrain with all-wheel drive and the most aggressive slope capability I've tested, up to 35 degrees. It's the go-to choice for properties with steep hills or uneven ground. Check the link below to see the current price. Pros: all-wheel drive with individual wheel motors maintains traction on wet grass, loose soil, or steep slopes where standard two-wheel drive mowers slip. Handles slopes up to 35 degrees. No other consumer mower in this price range comes close. RTK GPS with included reference station, no boundary wire, 1-inch accuracy. Covers up to 1.5 acres with extended battery option. Dual cutting blades with a wider 13-inch effective cutting path cover ground faster. IP66 weatherproof rating means you can leave it outside year-round without a cover, though I still recommend storing it in winter if you have snow. Cons:
significantly heavier than competitors, around 75 pounds. This matters if you need to manually move it or lift it into a vehicle for service. The AWD system is audibly louder. Neighbors may notice the motor noise more than with standard mowers. Requires reference station placement with clear sky view, same limitation as the Husqvarna EPOS. Smart home integration is limited. Basic Alexa and Google voice commands work, but no IFTTT or Home Assistant support as of early 2026. You get basic voice commands, like Alexa, start the Navimo, but you can't create conditional triggers like skip mowing if soil moisture is above X%. If you're building a coordinated smart yard automation system, this is a significant weakness.
One installation note: the heavier weight means this mower creates more visible track patterns in soft soil or wet conditions. If you have sections of yard with poor drainage, you may see rutting during spring thaw or after heavy rain. The EcoFlow blade stands out with built-in vision-based obstacle detection and an optional sweeper kit that picks up leaves and debris before mowing. That's useful if you have trees dropping material regularly throughout the season. Check the link below to see the current price. Pros: advanced camera-based obstacle avoidance detects and routes around toys, branches, and other yard debris without collision. Optional leaf sweeper attachment with a vacuum system clears debris before mowing. Genuinely useful in fall, less so in summer. Covers up to 3/4 of an acre efficiently with systematic mowing patterns. Solar panel charging accessory is available and extends runtime in sunny climates, though it only adds 10 to 15% capacity in practice. Excellent app interface. Cleanest, most intuitive mobile control of any mower I've tested. Works with boundary wire or virtual boundaries that are GPS-based with no reference station required. The vision system works impressively well in good lighting, but I've had homeowners report that the mower occasionally misidentifies shadows as obstacles and takes unnecessarily wide routes around them. It's learning-based AI, so performance should improve over time with firmware updates. If you're interested in the sweeper kit, understand that it's not a replacement for fall leaf cleanup. It handles light debris and grass clippings effectively, but can't manage heavy leaf accumulation. Think of it as a way to keep the mowing area cleaner between manual cleanups, not as a full yard maintenance solution. The Husqvarna Automower 435X AWD offers all-wheel drive capability at a lower price point than the 450X EPOS. It covers up to 0.8 acres with traditional boundary wire installation. It's a solid choice if you want AWD traction but don't need GPS boundary definition. Check the link below to see the current price.
All-wheel drive handles slopes up to 27 degrees and maintains traction in wet conditions. Reliable boundary wire system is time-tested perimeter definition that works regardless of tree cover or signal conditions. GPS-assisted navigation, this is different from boundary definition, learns optimal mowing paths over time for efficient coverage. Cellular connectivity is available as an add-on module, so you can upgrade to remote control and GPS tracking if needed. Excellent smart home integration, works with Alexa, Google, Home Assistant, and IFTTT. Quiet operation, significantly quieter than the Momotion AWD despite similar mechanical capabilities. Cons: requires boundary wire installation. Plan for 4 to 8 hours of labor on 0.8 acre properties. Smaller cutting width than competitors at 8.7 inches, takes longer to cover the same area. GPS-assisted navigation requires cellular subscription, around $10 per month after the first year. Without it, the mower still works but uses random patterns instead of systematic paths. The GPS-assisted navigation with subscription makes a noticeable difference in efficiency. I've measured 20 to 25% faster coverage on the same property compared to random pattern mowing. The automation learns where it's already mowed and fills in gaps systematically. If area coverage in the current zone is less than 95%, then identify unmowed sections, navigate to the nearest unmowed section, and mow with systematic parallel pattern. Else, return to dock and log completion with zone and coverage percent.
If you're choosing between this and the Mimotion Luba 2 AWD, the Husqvarna is quieter and integrates better with smart home systems, while the Mimotion handles steeper slopes and doesn't require boundary wire. Your property terrain and smart home priorities should drive the decision. Now let's cover some frequently asked questions. Do smart robotic mowers work with Zigbee or Z-Wave smart home systems? No. Robotic lawn mowers do not use Zigbee, Z-Wave, Thread, or Matter protocols as of 2026. All models connect via Wi-Fi at 2.4 GHz or cellular with 4G or LTE, and they integrate with your smart home ecosystem through cloud services like Amazon Alexa or Google Home, or API calls if you're running Home Assistant. This means they can't communicate directly with your Zigbee or Z-Wave hub. Instead, you'll create automations through your voice assistant platform or a hub like Home Assistant that bridges cloud services. Expect 2 to 5 second latency for any remote commands because they're processing through internet servers rather than local mesh networks. The lack of local protocol support also means your robotic mower requires internet connectivity to respond to app or voice commands. If your home internet goes down, only the mower's internal schedule will continue to function. How much of my Wi-Fi coverage do I need for a 1-acre property?
Your robotic mower needs reliable Wi-Fi coverage across the entire mowing area. Dead zones will cause the mower to lose app connectivity and may prevent it from completing scheduled sessions. Standard home routers reach approximately 150 to 200 feet outdoors in ideal conditions, which covers about a quarter acre at most. For 1-acre properties, you'll need either outdoor-rated mesh network extenders placed strategically around your yard, a model with built-in cellular connectivity that doesn't depend on home Wi-Fi, or RTK GPS-based navigation that allows semi-autonomous operation with intermittent cloud connection. In my installations, I've had the best results with outdoor Wi-Fi access points, like Ubiquiti outdoor units, mounted on exterior walls or on poles in the yard. These provide more reliable coverage than indoor mesh systems trying to penetrate walls. Before you buy any Wi-Fi-only mower, walk your property boundaries with your phone and confirm you have stable connection everywhere the mower needs to operate. Can I coordinate my robotic mower with smart irrigation systems? Yes, but the coordination quality depends heavily on which platforms your devices support. Basic coordination through voice assistant routines, Alexa or Google, lets you create simple time-based rules like run irrigation at 6 a.m., start mowing at 10 a.m. to ensure grass is dry before mowing. Advanced coordination requires a hub like Home Assistant that can read sensor data and create conditional logic. For example, you could write automation that checks soil moisture sensors and skips mowing if the ground is wet, or that delays mowing for 3 hours after irrigation completes. The challenge is latency and reliability. Because robotic mowers use cloud connectivity, your automations depend on internet uptime and cloud server responsiveness, typically 3 to 8 seconds for commands to execute. I've seen weather events that knock out internet service also break scheduled coordination between irrigation and mowing. The most reliable approach is to maintain conservative time buffers, 4+ hours between irrigation and mowing, and enable the mower's built-in rain sensor as a backup safety mechanism. What happens if my robotic mower loses GPS signal or boundary wire connection?
Failure behavior varies by model and perimeter system. This is critical to understand before purchase because the consequences range from inconvenient to potentially damaging. Wire-based mowers have the most predictable failure mode. If boundary wire is cut or disconnected, the mower typically stops within 6 to 12 inches of detecting the break and displays an error code. Then you repair the wire and resume. GPS-based mowers without reference stations, like the Segway Navimo, will continue operating using their last known boundary map when satellite signal degrades. They'll usually complete the current mowing session, but may drift 6 to 12 inches outside intended boundaries if signal loss is extended. RTK GPS mowers with reference stations, like Husqvarna EPOS, handle temporary signal loss better. They use dead reckoning, calculating position based on speed and direction from the last known GPS fix for up to 2 to 3 minutes, then return to dock if signal doesn't restore. Vision-based systems like the EcoFlow blade rely on camera-detected edges and will stop if they can't visually identify lawn boundaries. The worst-case scenario is a GPS mower operating in an area with heavy tree cover or near tall buildings. I've seen units wander beyond intended boundaries when signal is intermittent, especially on properties with ambiguous transitions, like lawn gradually fading into naturalized areas. How do I integrate a robotic mower with my existing smart home energy management system? Smart robotic mowers draw 50 to 150 watts while charging and negligible power while mowing since they run on battery, so they're minor consumers in your overall energy management strategy. The most valuable integration is charging schedule optimization if you're on time-of-use electricity rates. Using Home Assistant or a smart home hub that supports conditional automation, you can delay charging start times to off-peak hours. The logic looks like this. If current time is greater than or equal to 10 p.m. and mower battery is less than 80%, then enable charging. Else, disable charging. This requires either a smart plug between the charging dock and your outlet. We recommend smart plugs with energy monitoring so you can verify consumption, or direct API control if the mower supports charging schedule programming. Most premium models like Husqvarna or Mammotion let you set charging schedules through their apps without external smart plugs. The challenge is ensuring the mower has sufficient charge to complete scheduled mowing sessions. If you're too aggressive with off-peak only charging and a hot week accelerates grass growth, you may need manual intervention to get the mower charged in time. I recommend programming energy management automations to allow emergency charging during peak hours with push notifications so you're aware of the override.
The best smart robotic lawnmowers for large yards require protocol awareness and realistic expectations about connectivity. You're investing in equipment that needs reliable Wi-Fi coverage or cellular connectivity across every square foot of your property, not just inside your house. If you have 1+ acres and complex terrain, the Husqvarna Auto Mower 450X EPOS delivers the most reliable coverage with true wireless setup, though you'll pay for cellular subscription after the first year. For budget-conscious buyers willing to install boundary wire, the Works Landroid Pro WR147E offers excellent value and the best smart home integration depth, especially if you're running Home Assistant and want local API control. Remember that these are Wi-Fi or cellular devices, not Zigbee or Z-Wave components. Your automations will depend on cloud connectivity, and you'll need to plan your network infrastructure accordingly. The learning curve is real, but once you've verified coverage and tuned your schedules, a properly configured robotic mower reclaims hours every week during growing season.
That wraps up this episode of Smart Home Setup Podcast. Thanks for listening all the way through. New episodes come out every Monday, Wednesday, and Friday, so you've always got something fresh if you're working through a smart home project or just planning your next upgrade.
If you found this episode valuable, I'd really appreciate it if you'd leave a 5-star rating and write a quick review. It sounds like a small thing, but it actually makes a big difference. It's how other people who are searching for this kind of practical advice end up finding the show instead of just landing on product listicles that don't tell you anything real. And if you haven't already, go ahead and subscribe or follow so you get notified the second a new episode drops. See you in the next one.